All right. Good evening, everyone, and welcome to Strait Science. Strait Science is an evening science seminar series put on by UAF Northwest Campus in Nome and also UAF Alaska Sea Grant, also in Nome, and you're in the home office tonight. So tonight's speaker is no stranger to Nome. We're really just privileged to have Rick Thoman back. Rick Thoman worked for the National Weather Service for over 30 years. And when he got those guys all tuned up and straightened out, he decided to take it over to the University of Alaska Fairbanks. And he is with the Alaska Center for Climate Assessment and Policy. And he's going to give us a review of our wild weather of Western Alaska. And we've certainly had enough of that to keep us busy. So let's have a review and also hear what may be coming our way. So Rick, we've been all waiting to hear this one. And thank you so much for coming, and take it away.
Okay, thanks very much, Gay. And thanks everyone for tuning in. So the Halloween time Strait Science has become something of a tradition now. I believe that this is either the 5th or 6th Halloween week in a row that we have done this, and so I'm very excited to be able to add to the continuing this very useful tradition now. So let's see if we can make the technology work. Here's what I thought we would do. We're going to just do a review of what happened basically since our last climate review Strait Science, which was in May. So basically the summer and early fall season, just a little bit on what happened and why from the atmosphere and ocean perspective. We could talk for a very long time on highlights and unusual things that happened in the region in the last 5 or 6 months. We'll just touch on a few of them and then finish up with the outlook for the upcoming winter season. So starting off with the big view here. So we're looking down on the North Pole here. Alaska and Nome are down towards 6 o'clock there. Nome there indicated in the yellow dot. On the left-hand side are the temperature departures from average for the midsummer season. So June, July, August, that's on the left, and the precipitation as a percentage of normal on the right. Just looking at that left-hand side, the temperature graphic, you'll notice across most of Alaska and say eastern Russia in general, temperatures were not that far from normal. The exception there across the North Chukotka coast into the Bering Strait region for the 3 months, a little bit below normal. It's kind of hard to see at this scale. We'll see it a little better, but it was a little bit below normal eastern Norton Sound area. If you were with us last year at this time when we did our Halloween week briefing, of course, last summer was exceptionally wet across Western Alaska. This year, much less so. And you can see that looking around the Arctic, there's not too much in the way of large-scale pattern in the percentage of normal precipitation for the 3 months. Now that, of course, and we'll get into more detail, hides some of that shorter-term variability. But for the summer as a whole, pretty dry across eastern Canada, quite wet across Iceland, eastern Greenland area, and quite dry, especially there in portions of the Russian European Arctic, the same area that was very warm. But overall, maybe not as dramatic of differences from normal for the 3 months as we've seen in some years past. Okay, so why did we wind up with the weather pattern that we have? Well, here we are looking at the mid-levels of the atmosphere, kind of the climate driver level. And what sticks out to me as a meteorologist is we've got, for the 3 months, we've got low pressure centered exactly over the Bering Strait. And think about the winds rotating counterclockwise around low pressure in the northern hemisphere. So that overall, that directed precipitation into southwest Alaska, south central, but Bering Strait region, Seward Peninsula, more on the kind of north of the storm track much of the time. Certainly there were individual storms during the midsummer month, but the precipitation not nearly as high as farther to the south. You can see that big high pressure over the European Russian Arctic, responsible for the warm and dry conditions there, and the low pressure there over eastern Greenland, corresponding with the cool, wet conditions there. So as we hope that this works out, pretty good correlation between what's going on in the mid-levels of the atmosphere as the drivers for what's happening at the ground. All right, so stepping back to early summer, casting your mind back, here's a plot from the multi-sensor sea ice analysis here. This is from what's called the MAISY product. And this does a much better job with low sea ice amounts. This is a human aided product. It combines multiple sources. And so what I've done here is I've plotted up the last 3 years of sea ice extent in the Bering Sea, starting May 1st and then going into July. And the thicker brown line is about the 15-year median. And you can see that thick black line, which is this year. For most of May most of May, it was kind of between the last 2 years, popped up a little bit there at the end of May and early June as ice was slow to melt, basically in the western Gulf of Anadyr, northwest, before it finally melted out. But for most of the spring, we were below average early and then pretty typical as the ice decayed. Certainly less ice through May than we had in 2021. So that was the start of the early summer, jumping back now to the sea ice minimum. I like to show this just because it gets lots of press. On the left-hand side here is what the typical sea ice extent looked like on the day of the minimum for the first 11 years of the satellite record. And so this is a sea ice extent product. So it's either yes, there's ice, or no, there isn't. Of course, the real world is more complicated than that, but it's a nice, convenient simplification. And you can see, as you know, back in the day, typically somewhere along the North Russian coast, there was ice hanging in, and even having ice at the North Slope coast was, in this case, typical in the 1979 to 89 period. On the right-hand side is what the sea ice extent looked like, again, from the passive microwave satellite determination on September 18th this year, which was the date of the minimum. And you can see, just glancing at that, obviously there's much less ice, both on the Atlantic and the Pacific side. You'll notice that, in particular on that right-hand side graphic, a lot of open water in the Canadian Arctic waters there between the islands there. And in fact, according to the Canadian Ice Service, the sea ice extent along the Northwest Passage was the fourth lowest since the late 1960s. So pretty dramatic melt across that part of the Arctic. We did have about 6 weeks, 5 or 6 weeks, where there was no ice within 100 miles of any point of land on Alaska. Now, of course, for Nome and the Bering Strait region, the northern sea route, so the navigational route across the north coast of Russia is historically, was not viable very often, but has become so nowadays. And so here's our updated plot, the bars showing when, the period of time when that northern sea route was open water, so would have been traversable by non-ice hardened vessels. This year, over on the far right-hand side of the graphic, relatively late opening. Of course, we had the ice hanging along the North Chukotka coast very late in the season. We'll talk about more about that in a little bit. But eventually it did clear and then stayed open more than 2 weeks longer than it did last year. 2 weeks, I should say 2 weeks later in the season than we had last year, which was an unusually early closure for recent years. Of course, not, historically, often it would never open. So it's all relative, right? So as you can see there, the total duration of time that Northern Sea Route is open, longer than last year, but probably it was shorter, say, than the previous decade average. So here's from the National Weather Service Sea Ice Program, just the marching through time here, how the sea ice concentration looked. So June 15th on the left, July 15th in the middle, and August 15 on the right. And you can see nice retreat there. If you look on the North Chukotka coast, there's some interesting stuff going on. We'll talk about that more in just a few minutes here. Along the North Slope coast, it was really the last week of August when we got the ice to completely clear the coast. Again, that's typical or a little later than say recent decade, but historically, of course, unusual. All right, so let's zoom in now to our part of the world. So this is again now midsummer, but we're zoomed in here, and this is just the departure from the 1991 to 2020 average temperature for the 3 months as a whole. Nome was right on the dividing line between warmer than normal and cooler than normal. Nome Airport fell just inside the warmer than normal area, but you can see across Eastern Norton Sound, more decidedly warmer than normal. In contrast, through the Bering Strait, St. Lawrence Island, most of Chukotka was significantly cooler than the long-term average for the 3-month season. You can see the rest of most of southern mainland Alaska decidedly warmer than normal. Now, here's the high temperatures for the summer as a whole. Every day wasn't cool and rainy. We did have some warm weather, especially back in June, early June. Didn't have any daily record highs at Nome this summer. We did have a couple in May, but none during the core summer. 73 there at Nome Airport, 77 at Dexter was the high. Did have some 80s pop up Eastern Norton Sound area, including Unalakleet one day with some offshore flow. Interestingly enough, nowhere in Alaska got to 90 this year. That doesn't, most years do someplace, either somewhere in southeast, typically Hyder, or in the eastern interior gets to 90. We came close there with the July heat wave just east of the border, Old Crow 88, and up southeast of Koktovik, inland area there, got to 90. Can't remember what station that is. But at any rate, in Alaska, nobody got to 90. And 73 at Nome is not the lowest high temperature for a summer in recent years. Couple seasons have had highs just a degree or two lower. So precipitation, again, it was really a tale of two seasons. Not as dramatic in Western Alaska as, say, South Central, but still there was quite a difference. Of course, May and June are typically, so climatologically, dry seasons across all of mainland Alaska, but this year was even more drier than that, the normal dryness. Nome was one of the few areas that was relatively close to normal precipitation, and you can see on our climate analysis model here, which is where this data is coming from, there is a small area extending from Nome up towards Wales that is analyzed with close to normal precipitation, and this is independent of the airport observations. That's not part of this particular model. So that was quite a good pickup there by our climate analysis model. You can see portions of the Eastern Seward Peninsula less than half of a normal precipitation for May and June. And we did have especially during June, after snowmelt, we did have some low-level drought analyzed on the eastern Seward Peninsula and eastern Norton Sound coast as well. So that's early summer. And then the switch was flipped about the second week in July. Again, Western Alaska, kind of near the edge of the precipitation, certainly significantly above normal. Nome Airport, 125% of normal, but nothing like the Anchorage area, even down into Lake Iliamna area, where it was really, really wet. The other interesting thing to point out here, while Seward Peninsula and eastern Norton Sound area recovered, still near to even below normal precipitation across St. Lawrence Island, and solidly below normal just to the northwest of Gamble there on the Chukotka coast. So again, and this is not nothing terribly unusual, significant spread across the region. And it's, as a climate person, it's really exciting to me that we have the ability now to at least start to get a handle on that with these climate analysis models. All right, so that's temperature, precipitation. Let's take a look at the oceans. So May through September, so a 5-month season here. Here's the, for that entire 5 months, here's how temperatures on the ocean surface played out relative to normal. Very different pattern than we've seen some recent years, with generally cooler than normal temperatures extending really right through the Bering Strait all the way down to the Pribilofs, and really almost the only area in our region with above normal for the 5 months as a whole across Norton Sound, basically Gulliv and eastward there. And you can see that's wrapped down along the Yukon River Delta, but very different pattern. That's the first thing your eye notices, is that cool. But notice out in the western Bering Sea, where we have a really very warm water for the 5 months here, that darker color, that's more than 4 degrees Fahrenheit warmer than average for the 5 months as a whole. That is really remarkable for offshore. The middle of this area here is, you know, a couple 100 miles from land. That is really remarkable for a 5-month period. Very stunning. This portion, the Southwest Bering Sea here, has been warmer than normal most of the time for a year now, and was certainly manifest in the warm season here. So here's how, just for the northern Bering Sea, so basically in that little insert shows the area that these are the average temperatures for, again, for the May to September period. So this is basically from the Pribilofs northward and east of the date line. This year had the coolest May through September temperature, ocean surface average, since 2013, and obviously is very different than the whole spate of warm years that we had 2014 through 2020. But even though, oh, look how cool it is. Oh, it's really way below that, the green line there, which is just a smooth average. If you run your eye across, that's just below that 7 degrees Celsius, so about 45 Fahrenheit, you run that back. Prior to 1980, this would have been a really warm year. This would have been a near record warm year in the Bering Sea. And now we think of it as, ooh, look how cool it was. And that is a measure of how much things have changed. What used to be near record warm is now, ooh, really cool. That's the definition of a changing climate right there. It's really quite stark contrast there. All right, we're going to be hearing more about this in upcoming Strait Science, but I would be remiss if I didn't show the results from the NOAA trawl survey and the Bering Sea bottom temperatures here. And so to provide some comparison, we've got summer 2021 on the left and this summer on the right. The thing that really strikes me looking at this is looking at the right-hand side now. So this year's survey, notice these darker blue colors extend significantly to the southeast of St. Matthew Island. That's right here. And really down to about the latitude of St. Paul, to the east of St. Paul. That cool water was completely missing in 2021. Now this is the 2022 is not, we're not back to the heyday of the cold pool, but this is the best we've seen, this area of darker blue indicating water that's generally 1 degree Celsius or cooler. This is the best we've had in quite a while. And no surprise, of course, this is strongly reflecting the more southerly sea ice that we had this year, this spring, than we had in 2021, when we could barely get the ice south of St. Matthew Island. Much more extensive in the spring south of there this year, and that's reflected in the bottom temperatures. All right, so that's kind of the review of what's happened. All right, highlights here. And we've got, like I said, we got plenty. We could talk about these for a long time. Here's my little timeline. I really like these. We've been doing these for a while now, and these are becoming a really, for my climate purposes at least, these are becoming really valuable as a quick snapshot of what's happened. And so I'm glad that we're doing this, and I probably need to put these together so that I can share this resource out. Conveniently, starting off in the summer, this year, June 4 to 7, that had 4 consecutive days with highs in the 70s at Nome Airport. That was the longest streak of warm weather at the airport. Conveniently, I didn't have to change these dates from summer 2021, because you remember June 4 to 7, 2021, that was 4 days in a row of snow in Nome. So, which of course is not, Weather Service isn't doing snow anymore. That's not captured in the official climate data, but we've captured it here on Strait Science. So started off very warm with some record highs, a couple of record highs there before Memorial Day. In a pretty warm June. I'm sure no one that was in Nome will forget the Smoke-mageddon on July 1st, waking up to, you thought you climbed into a wood stove. And that was, of course, we did a Strait Science on that soon after that. And that was the result of smoke from the explosive burning of the Pike Creek and Coktuli river fires north of Iliamna Lake on June 30th, and approaching weather front from the Bering Sea moved that smoke to the northwest and trapped it in the lowest few thousand feet of the atmosphere. And so Nome, 450 miles from the fire front, was inundated with this incredibly thick smoke, as was almost everywhere between the fire and the Seward Peninsula. Eventually that smoke tracked all the way into the Chukchi Sea. And most communities in the region had reduced visibility for a day, half a day to a day, and at least a few hours of really poor visibility. We did have some snow in July. Doesn't happen every July, not of course unknown, but Nome did have the coolest day in July since 2012 on the 18th, snow on the hills west of Nome, and it actually did snow right to sea level at Diomede, at least some flurries. We'll be looking at this in more detail early August. We did have ice drift into the Bering Strait from the northwest. Kind of a curiosity as opposed to impactful, but it's been a long time since we've seen that happen. Nome's biggest rain came in the summer, came right at the end of August there, almost 2 inches of rain in a couple of days. Again, not at record levels, but part of this trend that we're seeing of more extreme precipitation events. 2019, of course, summer, we set the all-time 24-hour record rainfall in Nome And every summer since then has had high precipitation events like this. Nome is not alone in this. This has become very common in the last few years all around Alaska. And of course, in September, ex-Merbok. So I won't dwell too much on Merbok. You know far more than I do. I thought this was a really insightful picture that really painted the scale of what happened here. This is just when was this? The 19th, I think. This was taken a drone footage here. Really very impressive view of the washout there, just east of town. Really quite remarkable. As most of you know, Merbok was very well forecast as far as the large scale pattern. Here's a forecast from September 13th, and this is from a multi-model output here, and the black line is the average of all of the, there's 30 different models actually in this, and the black line there is the average, and that is almost exactly what wound up happening. The global models nailed Merbok as far as the track goes, very far in advance. We don't often get this lucky in the sense that sometimes big storms happen with much less lead time, but this was not the case with Merbok, and we could not have asked the weather models to do any better than they did with this. So days ahead of time, it was nearly perfect as far as the track. Other parts of the forecast, less good. Here's the graphic of what actually happened that I made up, and I put the dots there indicate where the center of Merbok was, and I put this on top of the sea surface temperature fields in August. These are rankings since 1900. It was very similar to this as Merbok was coming along. And what I want to point out here is that Merbok formed here west of Wake Island, a place in the North Pacific where, in the subtropical North Pacific, where typhoons have very rarely formed in the past because the water is not quite warm enough. But this year we were way above normal, amongst the warmest sea surface temperatures there in the last 120 years. And then as it formed, it passed over water that was at its warmest of any summer, any August since 1900. And that helped maintain Merbok until it transitioned from a typhoon to a more typical mid-latitude storm as it approached the Aleutians. But that drew tremendous amounts of warm air northward with it, lots of moisture. On the evening of the 15th, evening of the 16th, we had what seems to me to be the absurd situation. 10 o'clock at night at Unalaska, temperature was in the 70s with all that warm air that was brought north. And of course, it took the absolute perfect track to produce a coastal flooding across Western Alaska, passing just west of St. Matthew Island, just across the west end of St. Lawrence Island, and then into the Chukchi Sea where it weakened. Really, certainly one that we would never have seen. If you'd have talked to me on Labor Day, I would have said, no, we can't get a typhoon to form west of Wake Island. And that's important because that is a much shorter track into Alaska waters than the typical typhoons that form or at least move to south of Japan and then turn and either pass over Japan or just to the east and then get caught up in the jet stream. This had a much more direct path, and that was important in what actually happened here. Now we have we've added an arrow to the quiver of how can we get big autumn storms in the Bering Sea? Well, now we have to think about, are we going to get tropical storm formation in the seas to the south of Alaska, not just the far western Pacific? Here's a couple of graphics I pulled off after the event had peaked, and I just have these here to show the peak water levels as observed at Nome on the left and Unalakleet on the right. For Nome, this was the highest observed water level since the November '74 storm, 0.3 of an inch higher, or 0.3 of a foot higher than the October 2004 storm. Unalakleet, I don't think, was quite as extreme, but of course that gauge has only been in there since 2017. So this is the first big storm at Unalakleet that we have that gauge information for. I did learn just yesterday that while the state surveys are not final yet, the preliminary indication from Gullivan is that the water level in this storm was higher than any storm in the past century. There may be a storm, the October 1913 storm may have been similar water levels to this, but this was much higher than any storm in the last century at Gullivan, and hence all the damage there. And it really, again, sound like a broken record. We really need to get water level observations in these high impact events. And right now for the Bering Strait, Seward Peninsula, Norton Sound region, all we got is Nome and Unalakleet as far as real-time continuous observations, and we just have to do better than this. There's been more attention from the federal and state agencies, I think, following Merbach here than there was after the Bering Sea superstorm in 2011 or the series of storms in 2013. But we'll see what kind of resources actually get deployed. But getting actual observations, I think, should be the very high priority, because once we got observations, then we can get something like reasonable forecasts if we can get the storm surge models improved, which was definitely a weak point in the forecast suite for this ex-Merbach storm, where water level forecasts were not that good, to be frank. Now that I don't work for the Weather Service, see, I can say that. All right, ice in the Bering Strait. In early August, we had ice move down from the Chukotka coast along the west side of the Bering Strait. This was, to be honest with you, I was not expecting this at all. We had ice along the north coast in late July, the northwest Chukotka coast, but about the 8th of August, it rounded East Cape and moved south. This ice was visible by the 9th from the helicopter on approach into Diomede. And for the most part, this ice stayed on the west side of the Bering Strait. Eventually, basically the ice ran out of ice along the North Chukotka coast to move south, and it was pretty much melted out by the last days of August. But really quite a remarkable event there. You can see that in this false color image, that kind of turquoise color there is the sea ice, and the whiter stuff is some low cloud there, but you can see it's well southwest there of Diomede. Okay, so why did we have this kind of really bizarre thing? Well, the one thing we know is from the atmosphere, we had in early summer, we had persistent north winds across the kind of the western Chukotka area. So West Erangel Island there. This graphic is showing the rank of the north wind component. And those lighter blue colors indicate significantly more north wind than average, not at record levels, but like we have those, the darkest magenta colors there, say across the Sea of Okhotsk, were near the strongest since 1949. Wasn't at that level, but it was persistent, and it was much more north wind than normal. So that kept the ice packed in there. Especially as we went into July, as we saw open water show up offshore, it kept ice near shore. But then we saw that ice be transported to the southeast in the Siberian coastal current. Now, we have no measurements of that, certainly not in real time. And so it's a speculation. Was it stronger than normal? We don't know. That would be a very interesting research question. Was it normal? There just happened to be enough ice to move around? That could be too. The big question that many people had, of course, is when was the last time that we had ice in the Bering Strait in August? And the short answer is I don't know. And if there anybody on this call can remember, I would be happy to listen. The problem is, of course, we're so beholden to the passive microwave ice estimates in the Western science world, and they do not do well with low concentration ice in the summer. The standard product always has ice somewhere in the Bering Sea, actually has ice in Cook Inlet most of the summer too. It's not real. Normally we don't care because we know there's no ice there. So we don't have that remote sensing to say, oh, the last time this happened was X. I looked back from the early 80s when there was some fairly high ice years or very late melt out, but I could not find when there might have been ice, say, southwest of Diomede in August. That doesn't mean it didn't happen, but I sure couldn't find it. I do want to stress, back in the day, this was not uncommon. Ice would routinely move from the North Chukotka coast south through the Bering Strait, even to St. Lawrence Island in August and September. That has not happened in a very, very long time. But this process is definitely not new. We just haven't seen it for an age. Here's what it looked like on the sea ice analysis from the National Weather Service. So on the left-hand side, July 16th, open water there, or sea ice free, west of Kolyachin Bay, with the whole area there west of East Cape back to Kolyachin Bay was ice free. By the time we get to August 8th, there is that ice moving southeast along the coast, and it is rounded East Cape there, and you can see we've got moderate concentration ice there to the west of Diomede. And that moved around, and gradually some of it would melt out and get replaced. But by the time we get to late August there, the source region there along the North Chukotka coast east of Kolyachin Bay is pretty much exhausted. The ice is either melted or moved southeast, and it's melting out there south of the Bering Strait. So for the better, for 2.5, 3 weeks there, really 3 weeks in August, we had a little bit of ice there. Again, more of probably a novelty than impactful. Still trying to figure out how many walrus might have been on that ice. But at least from the Alaska side, it was kind of a gee whiz kind of thing. All right, that's some highlights. We'll finish up with the outlook for the winter. So here's where sea surface temperatures are now, this week ending on Tuesday. And interestingly enough here, we have near to above normal temperatures in the ocean now, extending from Bristol Bay all the way north to actually to the east there of Point Barrow. The cool water that's been persistent near the Pribilofs since the spring, since ice melt actually, is gradually eroding away. You can see there's not much blue color there, at least a degree below normal Fahrenheit left in the Bering Sea. And we still have that very warm water there in the western, southwestern Bering Sea. So going into our cold weather that we have now, ocean temperatures above normal, pretty much everywhere near to just a smidge below normal, kind of from the Bering Strait to St. Lawrence Island and south, but really nothing too extreme as far as cool, not like we had earlier in the summer. Here's the sea ice for October 26 for the last 3 years, 2020 on the left, last year in the middle, and Wednesday's analysis from the Weather Service on the right. The big difference, of course, this year compared to last year, there is much more open water in the Chukchi Sea than there was last year at this time. On the other hand, there is much less ice this year than there was back in the fall of 2020. We care a lot, of course, about freeze up in the Chukchi Sea, because that really, we need most of the Chukchi Sea to freeze up before we can get significant ice to move south of the Bering Strait and to St. Lawrence Island and then south. Of course, all we need is sustained cold weather to get the ice to form in near the Alaska coast in Norton Sound. But as you saw from the map, Gay today measured water temperature, Cape Nome of 41 degrees. We still got a lot of warmth in the open waters before we get ice. Of course, we are seeing some ice now, actually is reformed in Gullivan Bay and in Norton Bay as well. And we're starting to see some ice now in the brackish waters of the Yukon River Delta. Again, not that unusual for the end of October. But the lack of ice in the Bering Sea and the warm waters, that is going to be a factor for our early winter ice conditions in the region. Most of mainland Alaska now has snow cover. Here's a satellite, mostly satellite derived product as of yesterday. And this is just a yes or no. Is there ice? Is there snow or not? And you can see basically all of Western Alaska now is being analyzed with at least some snow cover. And that area that's analyzed as bare ground there, Bethel southward, they got accumulating snow today. So pretty much except for South Central, Bristol Bay region, and of course the immediate Gulf of Alaska coast, we've got some snow cover now. On the Russian side, Chukotka side of the Bering Strait as well, most areas have snow, although having that bare area south of Anadir is unusual at this point in the season. All right, so that's kind of the setup at the moment. As you may have seen in the media, we are all cruising for our third consecutive La Nina winter for us, and that is important for the winter forecast for Alaska. Just as your refresher, La Nina means that, exists when water temperatures are cooler than normal, basically from Hawaii on south and east in a narrow belt near the equator. Why does it matter if water temperatures along the equator south of Hawaii, 1,000 miles from Hawaii, are a degree cooler than normal? Well, that does not affect our weather. But how it does affect our weather is those equatorial sea surface temperatures in turn influence where those giant tropical thunderstorms form and persist. And it's through that connection with those big tropical thunderstorms and where they set up that modulate the jet stream as it comes off of Asia. And that is how it can affect very immediately our weather. During La Nina, we tend to find those big tropical thunderstorms are very far west, say north of Papua New Guinea over towards the Philippines. And that has the effect of weakening the jet stream as it comes off of Asia. And as a result, we tend to see more high pressure over the Bering Sea, more storminess in the Gulf of Alaska, a storm track that basically stays along the Aleutians or south. The other factor is that during these La Nina winters, we often see big swings in storminess, in temperatures during the course of the winter. All you have to do is think back to the last two winters, which were also La Nina winters, to see that. So sometimes, just like we saw with summer precipitation, just like we saw last winter with temperatures and storminess, that the seasonal averages can be very deceiving because you get big swings in between. So here's how a bunch of La Nina winters have worked out in recent years for Alaska, for Nome. And again, I've highlighted some years here that had some really big swings. You know, the winter of 1998 or 1988-89, which some of you will remember, that was the all-time record low in Nome, 54 below. That super cold January, but it was followed by a super warm February. So if you look at the seasonal average, oh look, it was a normal winter. Well, it was anything but normal, but the variability at the monthly or less time scale. Saw the same thing in 2021. Very cold January, but both December and February were warm. And so, oh, look, it's a warm winter. Well, maybe as a whole it was, but there was plenty of cold weather there in January. So that's a feature of these La Nina winters. Now, snowfall here since 1974, there's been 18 La Nina winters. And here I'm using the climate analysis model to extract snowfall, since we don't have complete measurements anymore. So I think relative to normal, this is probably a reasonable guess. And what I get out of this is La Nina is not a good predictor of winter, the full season snowfall here. The average here is very close to 100%. We can't say anything about what the total seasonal snowfall will be, knowing that we're going to have a La Nina winter. Last year, below normal. Previous two La Ninas had above normal. So it's really hard to, well, it's not hard. There's really not much signal here with La Nina and snowfall. How much snow are we going to get this winter? Can't help you there. All right, sea ice. National Weather Service Climate Prediction Center does run this experimental sea ice model. One of the outputs of this is date of first ice. And I like to show this every month on my ACAP Climate Outlook webinar briefings. They've really made a lot of strides with this product. And you can see here that the forecast that was made at the end of last month, so this is getting kind of dated now, still kept some open water here just north of the Bering Strait into early December. Basically got the ice to just south of St. Lawrence Island by the New Year's, and then progressed it south. All in all, this looks pretty reasonable. You can see Norton Sound here icing up during November. That is not unreasonable at all. So we'll see how this works out. But overall, this looks like a pretty typical ice progression as we go through the season. So that's just the freeze up date, the date of the first ice, actually. One of the things that I've been interested in as kind of as a research topic is, can we use the late summer sea surface temperatures as a tool to forecast sea ice extent? And here's the plot here. This is kind of a technical thing, but I think you can grasp it pretty easily here. Here's last year, the late summer, so July through September, sea surface temperature for the northern Bering Sea was here, about 49 degrees was the average. And this is where the average February, March ice extent ended up here. So this year, the average July through September temperature is over here at about 47 degrees. And so my little scheme here would suggest that we're going to have a February, March average ice extent right in this band here, which would be very close to normal, or I should say the long-term average. We don't have any normals, we just have averages anymore. So the sea surface temperatures being cooler than most recent years would support the idea that we would have at least a near normal sea ice extent during the late winter and early spring. And I don't show it here just for the interest of time. The climate models that do sea ice also suggest a near normal late winter, early spring sea ice cover in the Bering Sea. Ocean temperatures are forecast to remain significantly above normal. Notice this is not a plot of temperature departure from normal, but rather this is the chances that the sea surface temperature will be significantly above normal. Almost the entire Pacific basin south of the Aleutians is tilted to favor warmth. The Bering Sea, there's not much tilt except in the southwest Bering Sea where it's been warm for a year. Keep on keeping on with that. So again, it looks pretty darn warm across the Pacific. This has potential impacts for us. If this water is really warm, there's going to be that much more moisture to stream northward if and when we get the storm track to change so that it's moving storms through the Bering Strait Sea and towards the Bering Strait. They could potentially have much more water with them than historically average. Last group of slides is the CPC outlook. Climate Prediction Center issued these last week. Here's the outlook for the early winter season, tilting to favor significantly above normal temperatures across all of Western Alaska and significantly above average precipitation. You can see there Western Alaska is alone for most of the state. Most areas have no tilt in the odds here from the Climate Prediction Center, but Western Alaska, both temperatures and precipitation favored to be above normal. Similar story for the midwinter season, but now we see a tilt towards below normal temperatures across southeast. The southeast part here would be a typical La Nina. There's not much typical there, as we saw with the temperatures there in Western Alaska because of these big shifts. But CPC going to favor continues that warm and wet tilt in the midwinter season. Now, as we move into the new year in the late winter season, we lose that warm tilt across Western Alaska for the January through March period, but we keep this tilt to favor significantly above average precipitation. A lot of this higher precipitation is predicated on a more westerly storm track that at least brings in some episodes of high moisture content storms. So here's your summary for you. I think for the main thing really with the forecast is expect repeated swings, warm to cold and back. There is a potential for very stormy periods. So we'll see how it goes. Sea ice freeze up is going to be later than last year, at least, because of the lack of ice in the Chukchi Sea right now. So I will just have to say Koyanak, and thanks for listening. Appreciate it.
All right. Wow. Thanks, Rick. Holy cow. I don't know whether to think about getting a snow shovel or an ice pick. It sort of sounds like we could be a little of everything. So at this point, before we do questions, everybody, if you can, put some kudos in the chat box for Rick. He has had a long day like everyone else, but he's already been, he was saying earlier, he's been talking on Zoom since 6 a.m. this morning. So, so thank you, Rick, for giving it to NOAA as well.
You bet.
And if there are any questions, there's no callers, so we'll take questions right up. And so if anyone has a question, I know I do. Actually, if Charlie Lean is still on, I think the answer from my perspective, and I that's why I'm asking Charlie, is the last time ice was in the strait in August that I'm aware of was the time in the mid 90s, 1990, and I can't remember, 1996 or 1995, when the boat was lost crossing from Wales to Diomede that had children. And I believe there was ice that had showed up, and there was a lot of hope that they had headed that way to the ice, and it slammed around the corner and came zipping down. Charlie, if it's Charlie Lean that's on, do you have any remembrance of that SAR case? What exact year that was? It was.
No, I don't.
Okay.
I vaguely remember the incident, but
They were all lost.
yeah.
Do you think it was 95 or 96?
Yes.
I'll dig into that.
Okay.
Thank you very much.
Yeah, and it was like it was the same kind of time. It was mid-August. And 2 boats were transiting, and it got rough, and 1 boat made it and 1 boat did not. And it was noteworthy because at that time they could not get permission to fly into Russian airspace for 3 days. And there were children involved in this situation as well. So it was really heartbreaking and memorable, of course.
Also in, I think 1990, we didn't have the shore fast ice go out in Nome until July 1st. So that was a real late year.
Not 90.
90.
And here's why I know that, Charlie. I did the polar bear swim that Memorial Day.
Oh,
Might have been
Okay.
89. That could be.
okay, maybe 89. I remember taking my kids out in a boat and standing on shore fast ice that day, July 1. I might be off a year. Yeah.
I'll check it out.
And the ice may have come down since then, but in August, but that one stands in my mind.
That's great. Appreciate it.
Megan Gannon has a question for you. She's with the Nome Nugget. Go ahead, Megan.
Thank you, Rick. That was great. I just was wondering if you could talk a little bit more about that persistently warm sea surface temperatures on southwest of us in the Southwest Bering Sea. Do we know what is driving that, and how much longer it might continue?
Yeah, that is a very good question. And the short answer is that I don't know. I'm trying to share my screen again here, just so I have something to point at. Can you see that?
You are not sharing your screen at this point. It should be now you are.
Okay.
You-
Okay. So what I think is going on is that, as I said, this area back down here, so here's Attu. This area has been warm since about this time last fall. And as I said, the magnitude of these departures here for open water is really quite remarkable. And the persistence is quite remarkable. This is part of a larger pattern that this warm water extends, back to Japan. And as you saw in that forecast, extends across much of the North Pacific. I believe that is the connection for this warm water. And some of what's going on here is it's continuing to move this comparatively warm water from off of Japan up along the Kamchatka coast here into this area. This is all, of course, occurring on the backdrop of sea surface temperatures globally are warming very steadily. The secondary factor, I think, is just, especially this summer and fall, is until recently, there's been not much storminess in this area. And this accounts for some of these very high departures from normal back here. We didn't get the usual number of storms to help mix the water during the summer season. So we had this thin layer. I think we had a relatively thin layer of very warm water due to the lack of storminess. But clearly this extends to depth. As we see now, this actually had mostly, not entirely, but mostly weakened or gone away as we got some more storminess in this area, starting with Merbach, but then several other storms that affected this area. But this has now reemerged, and I believe that's because this has been warm for so long that warmth has penetrated to depth now, and so it will take months to completely erode out that water because of the very high heat content of water. It's dense. takes a long time to change the temperature over a significant volume of ocean. So I think it's a combo of warm water in the far western Northwest Pacific moving into this area, and then the weather conditions conspired to maintain it. Does that make sense?
Yeah, thank you.
All right, thanks. I've got a question, Rick, and that is on slide 15. So I was looking, and I know we're going to talk about this next Thursday. Dwayne Stevenson's going to talk more. This is from his cruise and everything. But one of the questions is, like, to me, yeah, I see more blue, but I also see more brown, or whatever that is, darker orange. And so I wonder, is there, I'm guessing this is all coming from rivers, and why would it be getting more? I mean, it must not be, if there's colder water, it must not be because the ocean, it must be from the rivers. Is there anyone looking at, like, the heat in the rivers coming out sort of overall, and why that is?
Yeah, so
like right there, Bristol Bay, right up Nunavak.
yeah, so my understanding, this would be a good question for Dwayne, but my understanding is, of course, this part of the Bering Sea, this is all very shallow water. This is all really shallow, and so the temperatures that are reported here depend very much on the time of year when this survey is done. And even if this box is done, say, a week later this year than last year, that can make a difference in this very shallow water. And that's the reason for this sharp break here at Nunavak Island. These are different legs of the cruises. So I think that some of this is just the dates of the survey in this very shallow water. Makes less difference farther west where the water is deeper. This is my understanding.
Right.
But so I think that's part of the equation. But, like on the Yukon River, water temperature is routinely measured at one gauge there at Pilot Station, and that's it. There's no other river temperature. There's nobody is monitoring in a real time of publicly available basis, on the Koyuk River, on any of the rivers flowing into Bristol Bay. There's some stuff being done, but it's generally not readily available.
Right. Wow. Thank you very much. I just noticed that, and it just is persistent and seems to be growing, but maybe that's just, like you say, an artifact of the date. Like, I just see more cold and more hot. That's interesting. All right. Any other questions? All right. Dean Stockwell, go ahead. Thanks.
Hey, Rick, nice talk as usual. You covered a lot of information on sea surface temperature and ice distributions. And you talked about storminess. And I guess being out in the Chukchi Sea this year, it seemed unusually very, I'm not going to say stormy, but the wind patterns were very dynamic. We'd get winds from the north, we'd get winds from the south, and the whole system seemed very choppy. Do you do anything with a type of wind analysis in the region that you can compare to past years? This just seemed like an exceptionally rough year as far as being on the Chukchi.
Right. So yeah, the whole storminess question is just is one that get asked about so much, and it's so important. And at the moment, we don't have a good way to analyze that, especially in historical perspective. Some of it is that what do we mean by storminess? The way a meteorologist thinks about that is different than somebody on a boat, I think. which is perhaps different than the way someone thinks about it, going about their daily life in Nome. But those problems we can probably work with, but we need a way to really be able to quantify that so that I can start to answer questions like, oh, it seemed unusually stormy, was it? And that is something that if I ever get some free time, I would really like to think hard about, and I'd appreciate any advice or input on the parameters, especially that are important to you in assessing, oh, it seemed really stormy or seemed really not stormy. Because I think we have the tools now to allow us to start to address this, but it's going to be pretty data intensive. A lot of horsepower is going to have to go into it. So I want to have it's probably not the kind of thing that is going to be amenable to throw everything into the pot and see what comes out. We need a little bit more targeted effort to make it a tractable problem. So that's a long way to say, Dean, I can't help you, but I really want to.
Yeah, no, I agree with you. And I know if you had a satellite way of doing it, it would be a lot easier. But all you really have are the weather stations in Utqiagvik, Point Lay, Nome, and down the coast. And that would take a tremendous amount of analysis to do. So I see where you're coming from, but it just seemed being on the Chukchi this year as opposed to all the years I've been out there, it was unusually choppy, if you will. Yep, thanks.
And what time of year were you? Oh, I'm sorry, Rick. What time of year were you out there, Dean? Just so everybody knows.
July, August, and into September.
Okay, thank you.
Yep.
So I moved back to this slide. So this is from our computer analysis model, technically called reanalysis. This is available at hourly intervals going back to 1950. Every hour, it's got everything that comes out of a weather model. So we do have the theoretical ability. It's a big data problem, but the information's there that we could use this to crunch, at the hourly level, winds or seas or swell heights, swell directions over, any of this domain. It's global model. And that's why I say we can't throw everything in a pot, but we do have, I think, the information to get at this if we can figure out exactly what we want to measure. And maybe it's some kind of, like you said, choppy this year. Well, maybe we need to look at reversals in wind speed or wind directions above some threshold speeds or something like that. But I think we can get at this with the tools that we have available.
Yeah, I think it's there. I think it would take a lot of work. And, being out at sea, I know this year was unusual. We had the big HAB event take place. And I was out there on the Norseman seeing this thing unfold. And the thing that struck me is we can have the same event take place 3 times in a row, but the wind will either deliver it straight to the north or it'll bring it onshore towards Shishmaref in the Chukchi. And those are the types of things we see as a biologist. And it's just so hard to put it in context to anything else, because I know historically those HAB events have taken place in the past, but not have had a deleterious effect on the coastline. And it's just a thing we could talk about maybe later. So yeah, thanks. Good perspective. Really appreciate it.
Thank you.
Thanks, Dean. I'm looking to see if there's any questions because I have a bunch, but I don't want to hog up the airwaves. So bust in, raise your hand or make some noise if you want to ask your question. My other question is, you said this is our third year of La Nina. Now, I don't know much, but I thought, if I remember right, I was taught it's La Nina, La Nino, La Nina, how weird is it to have 3 La Ninas in a row, or is that considered a okay, normal sort of?
So the way to think about La Nina is really the equatorial Pacific normal on steroids. So it's an enhanced normal, and that's different than El Nino, which is really turning normal on its head. So it turns out that having 2 La Ninas in a row is not uncommon at all.
Okay.
Having 3 in a row has only happened 2 other times since 1950. Once in the early mid 70s, and once right around 1999 to 2001, 2. So that's only happened twice. This will be the 3rd one. We've never, in our comparatively short period of record, there's never been 4 in a row. And most of the tools suggest that this La Nina is going to collapse pretty quickly late this winter or early in the spring. That won't matter much for our winter forecast because of by the time this happens, it'll be mostly baked in. But at this point, we have no reason to think we would have an unprecedented 4th. It's very, very rare to get 2 consecutive El Niños because it's so different than the background state that the equator wants to be in.
Okay. So I guess what I'm hearing is, don't unbuckle my seatbelt yet until it just seems like we could go super cold like last, everybody, Rick was saying when we were just chatting before it started, remember last year, what did we have in November? What was that minus 30? Do you remember when that hit, Rick?
Yeah, right at the end of November, but November, there was that storm right at the beginning of November, like the first day or 2. And then it was quiet and cold, and then really cold the rest of the month. Bethel had almost the coldest November record, not quite that cold for Nome, but it was way, way below normal. And then we had the lunatic December.
Yeah, then we had all that rain, and you did too in Fairbanks. And I mean, that was Crazyville, and it turned to ice, and the animals were having a hard time. And yeah, I'm not looking forward to if we're going to go through that.
But that kind of dramatic swings, hopefully we won't repeat that one. We probably won't. But big swings during La Nina winters are the norm.
Okay.
When they occur, we'll have to see. But it would be unlikely, say, that we would have November, December, January, February all be below or above normal.
Okay. So keep it low and tight with your belt.
Yeah, absolutely.
Yeah. Hey. All right. And then last but not least for me, and then somebody else jump on. This Murbach thing came in like a son of a gun, right? And it was early September. And I remember somebody somewhere telling me at one point it was a 737 millibar low. I don't know where. That must have been down when it was maybe in the typhoon phase in the bright red. I don't know. But that was an incredibly powerful storm. And being so early, is this something, with the warmer waters that I know people have been asking, is this something that we have to put on our concern list? Like, be ready for these kind of things again? I mean, that was mid-September.
The short answer is yes. We've added one more way to get a big storm in the Bering Sea. If we can form typhoons this far east regularly, and that's coming because the oceans are warming. Will this happen every year? Of course not. Will every typhoon that forms in this area move to Alaska? No, you've got a whole bunch of other ingredients that have to come together. But now we've gone from can't happen to can happen. And so we have one more way to bring a big storm. And if it's going to be down in here, it's going to be relatively early in the season. Yes, we have to be prepared for this because it's going to happen again. It's just a question of when. And as we go through the coming decades, typhoons forming in this area and moving to Alaska are going to be more common. That is a certainty because the waters here will be warm enough to support typhoons.
All right, well, thanks for cheering me up on that one. I'm adding typhoons. So to me, harmful algal bloom was the thing that we have to now live with, right? We have to keep that. That may not happen every year, but we certainly saw that happen this year. And so that's going to be something in my mind, which is another thing. And now I'll add potential typhoon.
Yep.
All right. All right. Well, thank you so much, Rick. I mean, honestly, that was a lot of information and all of it good. Oh, Dean's got his hand up. Go for it, Dean.
Yeah, I'm going to hit you with another one, Rick. You've been primarily Nome and Western Alaska centric. I'm going to take you to Fairbanks this year for the winter. And I'm going to say, usually La Niñas bring extra storms to the Bering Sea. The lack of ice cover in the Bering Sea allows a lot more evaporation and moisture to get it up into the atmosphere and come into interior Alaska. Last year we had the big storm that also brought ice. What's kind of your forecast for this winter in Fairbanks, being a La Nina year with low ice cover?
So probably won't be too different in the sense that high variability, cold snaps and then milder weather. The potential for big snows are there with until we get the ice down pretty far south, which will take until late winter, early spring. The tough thing for Fairbanks is that it all depends on getting the winds aloft out of the southwest. If they're out of the south, all of that moisture gets stripped out by the mountain ranges, and it can be mild, but they get many feet of snow. Talkeetna land and Fairbanks gets nothing. On the other hand, if it's just a little bit more southwesterly, then we can get dumped on here. The best way to get that southwest flow is high pressure aloft over the Gulf of Alaska and have a storm or storms move through the Bering Sea and then track this way. And that's, of course, exactly what happened last December, with the 67 degrees at Kodiak on the day after Christmas, 5 days in the 50s in Alaska, high pressure down here. If we just have low pressure here and winds are south, then it'll be a different story. Snow forecasting, always very tough on the north side of the Alaska range.
Thank you much. Appreciate it.
All right. And good question, Dean, from the Metcalfs. That was their question too. And Megan, your hand is back up. So I'm thinking you'll bring us home with a question.
Great, thank you. Yeah, Rick, I wanted to ask you about what you said about lacking some good measurements for the floods that we experienced during Exmourbach. And I was just wondering if you could talk a little bit more about what it would take to get better measurements. And I don't know if I imagine that a lot of the remote sensing tools that are out there now wouldn't be able to do some of those short-term measurements. But yeah, could you talk a little bit more about what it would take to get better data on inundation for a storm like the one we just had?
So I think right now we have the best opportunity that we've had in a while, and are probably the best opportunity that we're going to have for a long time to come. I think it's imperative that folks in the region advocate to NOAA, to the congressional delegation, particularly for ocean water level stuff. There is no remote sensing that is at a high enough scale that it could supplement actual observations. So it is absolutely critical for things like ocean water levels that we have those at communities. That's, to my mind, this is Rick Thoman's opinion, that is far more important than, say, establishing one more buoy in the middle of the Bering Sea, far from land, where remote sensing, satellite-based estimates, for instance, of wave heights are pretty good. There is nothing like that for ocean levels, water levels at the community scale. And, you know, this ex-Murbach has shown that, you know, we have very vulnerable communities. There absolutely, in my opinion, has to be some continuous water level monitoring at Gullivan. They are so susceptible there that we absolutely have to get something there. Same at Kotlik. We just have to get more of this, and now is the time to do it. There are lower cost alternatives than the full, you know, NOAA water level gauges like at Nome and Unalakleet. I think that the region deserves that. But DGGS, for instance, has a number of these platforms out at some communities, none in the Bering Strait Norton Sound region, but like they have one at Kotzebue, one at Kivalina, a couple down Kuskokwim Bay and south, that provide adequate information. We need to do something because there's no alternative for water level information except right on the ground, on the ocean observations.
Does that answer it for you, Megan?
Yeah, yeah, thanks a lot. That's great.
All right. And thank you, Rick. It's coming up on 8, so I know we've kept you quite a long time. Does anyone have any last question for Rick Thoman? We're really grateful, Rick, and we look forward to your return as always. And just thank you so much. So for those next week, we're going to do Strait Science, but it's going to be on a Friday night at 6:30. And it's going to be, so Friday, November 4th, and it will be Dwayne Stevenson. He is the NOAA Race Division lead for the Northern Bering Sea Bottom Trawl Survey. And he will be giving the results. Why on a Friday is because he's going to Savunga to give it first to Savunga. So Savunga, St. Lawrence Island will get the full understanding of what he found, of what the NOAA Race Division, which is the research arm of NOAA Fisheries, what they found. Then he'll be coming to Nome on the midday plane out of Savunga, I believe, and he'll be at Northwest Campus. It will be hybrid. We will have Zoom, and it will be in person if people want to come down to Northwest Campus in the Nagazra conference room. And we're just really grateful that NOAA Race Division is actually, they're taking it totally seriously and actually sending their person. So I think we're coming back to, I'm glad on all kinds of reasons we're having people show back up in the region personally. So that's great from afar. And also we will keep it Zoom so everybody can join, but that should be a very interesting one, especially Rick, you've kind of, you know, you guys are the 1-2 punch. You just gave us the climate, really interesting about the warm water and all that. And then what he's got to tell us about what happened this summer for the Northern Bering Sea Bottom Trawl Survey. So with that, we'll hopefully see you Friday. Rick, if you want to stay on for one little second after, that would be great. And we'll see you Friday night. Don't miss that one. 1-2 punch, Rick Thoman, and then it would be Lyle Britt, but now he's become Dwayne Stevenson's boss. So Dwayne is the one that is most involved in it. So he's coming all the way up. With that, thank you all for coming, and we'll see you next time. Have a good night.
Thanks, everyone.